Now we have a demonstration of the software, which is a KilnSimu software. Probably you might have heard about it. And I'm very pleased to do this presentation developed by Cassie, Karri, Stephan, and I. And today I will do this with Karri and Cassie, who is joining us online for the demonstration. And Karri will shortly come up on the stage later. Okay, so Cassie, I have heard a lot about KilnSimu. So could you please tell me what is KilnSimu?
Yes, of course. If you can go to the first slide. So we have a schematic of a rotary kiln up at the top here, but it is a long, basically tunnel furnace, and it rotates. And it's very difficult to see what is going on inside of a rotary kiln. So KilnSimu is a software that was developed in a partnership between VTT and GTT. So Karri is from VTT, and he will talk at the end of the presentation, but it uses software from us and databases from us. It was originally developed to model cement rotary kiln processes, but now we have 10 other process model units. And Karri is actually going to talk about more that he's introducing now. Rotary kilns are common separator reactors in the mineral processing, metallurgical, and chemical industries. They can do things such as the production of activated carbons, alumina, cement, calcination of coals. We have customers using it on the reduction of ilmenite, waste incineration, metal recycling. And most of the kilns operate in a counter-current fashion, which means the material comes in on one side while fuel and the flame are on the other side.
Mm-hmm. Okay. So what is, the attractive features of KilnSimu, and why should somebody use KilnSimu for real life processes?
So in general, there's an increasing interest in the chemistry of a rotary kiln. It's not very easy to go inside of a rotary kiln and pull out material and figure out what phases you have. And there's an increased variability in starting feedstock chemistries or fuel chemistries. Some of it is due to the need to decrease emissions. There's also a need to reach new properties, whether that be small specification excises for existing materials or completely new materials. So a lot of companies themselves develop things, models with computational fluid dynamics. This is not a computational fluid dynamic model, so there are things that KilnSimu cannot do. So CFD models normally have like flame length and flame information, gas flow patterns, pressure distribution, and stresses on the kiln, whereas KilnSimu does not. But what the advantage that KilnSimu has that no other software does is with the thermodynamic databases we have running with KilnSimu, you can calculate the thermodynamics happening throughout your entire process. So you can see how changes in your feedstock or fuel will affect the chemistry and composition throughout your entire process. We've also had customers that link KilnSimu and a computational fluid dynamic model with Fluent or Ansys, and we can help with that if that's something that a customer is interested in.
All right, so now I'm convinced that I need to use KilnSimu. So what do I need in order to be able to run KilnSimu, Cassie?
So the things you would need for KilnSimu are twofold. So we obviously need process data. You need to have your feed compositions, your operation conditions, the information about all your process model units, whether it's your kiln dimensions, rotation speed, but you also need thermodynamics. So the thermodynamic file comes also from us. And then it runs on a command shell executable, so just a command prompt. So this can be run on any Windows computer. And in the background, it talks to our ChemApp software, which you've heard a lot about today. And it calculates the thermodynamic equilibrium at every single step along your process. And it also includes kinetic models into this to account for the kinetics. So as Shivani already put up the blue
Sorry.
box, no, it's okay. The process data is input into Excel at no additional cost. So Excel is built directly into KilnSimu. However, this is very difficult to get started with. Also, if you have a complex process, it's pretty difficult to set up. So we've worked to build an interface with KilnSimu, which is a third-party software. So it's not run through us, but KilnSimu works with them. We will show KilnSimu today in the demo, and it's highly recommended that you purchase it, but then you have to purchase an KilnSimu license additional to the KilnSimu costs. For the thermodynamic file, you have two options. So if you already have a FactSage license, you can generate your own CST files for KilnSimu. It doesn't matter which database you have a license to, you can use them and run as many CST files as you want. A lot of customers that use KilnSimu do not have a FactSage license. They do not have access to FactSage databases. And in that instance, you can purchase a standard KilnSimu CST file. We have standard ones for standard applications that we're used to, but we always share what elements and phases are included in our standard files, and we can always add new elements or phases necessary for your production process. The plus side of doing it without a FactSage license is it's less expensive. The downside is if you process changes in 6 months and you need a new CST file, then you have to get a new quote from us. And if you have a FactSage license, you can just generate a new CST file directly.
All right.
For the actual KilnSimu license, you can purchase a license similarly to FactSage for 1, 3, or 6 years, and it comes with a dongle.
Okay. So now I'm more convinced to use it, and I have bought this KilnSimu.
If we just click one more time, just a summary of the 3 costs. So you have to purchase a KilnSimu license, you have to have a FactSage CST file, and then you have the option of purchasing the KilnSimu interface license.
Okay, so now I would like to know, how does it work?
So we've set up a demo, which Shivani and I are going to go through.
Yes.
So this is KilnSimu, and this is what you would see. We did see a lot of demos this morning where they started a bit from scratch. I did not do that. So I have a demo of a cement kiln process. This, I mean, you could do it any way you wanted to, but I'm going to give you a brief introduction of the demo that I have here. So over on the right-hand side, you have your feed box, which is your, or sorry, on the left-hand side, you have your feed box, which is your feed coming in. On the right-hand side where Shivani's mouse is all of the current process model units. All you have to do is click and drag one in. Similarly to the demos we saw this morning, you can see on each process model unit white or gray boxes, and that indicates a feed flow going in or a feed flow going out. So for the cyclone down there, it has 4 white boxes, but only 2 feeds are currently active. And it has 2 gray boxes, so it has 2 output feeds going out. You can also see the numbers that appear just automatically on the screen. These are throughput numbers. So over by the feed box on the left where it says 300 tons per hour, it's white, and you can change this. So you can change your initial feed throughput, you can change the units, you can change the 300 value, you can change it directly here. If it's grayed out, like by the cyclone, then this is the feed rate coming out of the product from the cyclone. So this is a result, and it's updated during the simulation, which is why it's grayed out, because you can't change it yourself. And so for this cement demo, we have different process model units included. Most people can understand what mixers and splitters are, but we have 4 cyclones, which separate your particles from your gas phase. And if you scroll down, Shivani, the cyclones eventually lead into a calciner. A calciners normally allow for a higher temperature to start. It's basically a preheater to start the phase transformation you want. And then you go into your rotary kiln. And then after your rotary kiln, you would have some sort of cooler to cool off your product before it becomes your output product, or clinker material in cement cases.
All right, Cassie, but this is for the cementing process. What if I have another process in the rotary kiln? Then I have to create, I could create my own flow sheet in this case, right?
Yeah, so you can always open this XtendSim and start from scratch, you would have a white screen to start with, and you can connect as many process model units as you want or as few as you want, and you can easily see the flow of all of them, which we can look at in a minute. The only thing that has to be consistent for all of the setups is if you scroll up to the top, there's a model block on the left, and this model block has to be used at all times. If you click on it.
Mm-hmm. All right. So do you want me to go to the model block?
Yes, please.
Okay.
So if you always have to include this model block because it's what sets up the original simulation. So it is what pulls in your CST file or dot file, and it's what has your original simulation parameters. All of the process model units follow the same setup where they have tabs at the top that you can click on. So the tab we're on right now is thermodynamics, but you also have simulation, properties, and then you can go over to the results also. So the thermodynamics tab is where you can put in your CST file or pick your kinetic model that you want to use. If you click on the simulation tab, you can simulate or output results. So the cool thing about XtendSim is you can look at results directly in XtendSim, which we will show you, but you can also output results to an Excel file. The results tab in this model block has a set of results charts that will be plotted in Excel with the raw data that is in the charts. So it is easy to show. So you can share company-wide different charts and different results, and they automatically plot when you click this Excel button and pull them out.
Okay. And what if I want to vary some parameter and then see how does it affect my whole process? So do I need to, I mean, when I want to simulate cases, can I have to do one by one, or is it possible to also do it simultaneously?
Yes, so a lot of customers are interested in how small changes in fuel or small changes in additive or small changes in impurities will affect their results at the end. So Karri has set up that you can run multiple cases in parallel where you look at a small change or a large change for that matter, but you can run them in parallel and plot the results in parallel so you can see how the changes are affecting your overall results. And in that case, instead of clicking the simulate button on the top right, you would click the simulate cases button, and then it would run the multiple cases you have set up. And if you
Wonderful.
click on the results tab briefly,
Mm-hmm.
the results tab here, like I said, has a standard amount of results that you could plot with each run, but it is very easy to change these or to set them up in a way that you want. We always give customers a demo file to get started with, and it has a set of standard results, but you can always add another row in or delete one of the ones we have or anything like that.
All right. Okay.
So now if we want to go out of the model block, maybe we could look at one of the rotary kiln process model unit. So we don't have time today to go through every single process model unit here in this demo, because we are going to show some results. But if you click on the rotary kiln, all of these are set up very similarly. So they have the same tabs at the top, and you can put customized information for all of the process model units in. So obviously the properties tab is where you could name it. It's automatically named kiln, but you could change the name. You can put information about the inclination, the rotation speed, and this is customized to each of the process model units. So when you open the cyclone or the cooler, there's other things you can put in. But then if you click on the connections tab, this shows you all of the inputs and outputs. So for instance, in this scenario, we have a bed input, a fuel input, two air inputs, and then we have the bed coming out, the bed material coming out, and the gas product coming out. The good thing is you can control their positioning. So as I said, normally for rotary kilns, you have the bed coming in one side and the flame and fuel coming in on the other side, but you can control where your air inlets are throughout your rotary kiln. And you can control initial temperatures at the graph or at the table below. And if you click on the geometry tab, this is where you would customize your actual rotary kiln or your cooler or your calciner. You can click this plus and minus button to add more sections. So in this demo, we have one section and we say our rotary kiln is 80 meters in length and it is the same diameter throughout the entire 80 meters and it has the same two walls. So normally rotary kilns have a refractory wall and a metallic wall, and you can put the thickness of both of those in there and the conductivity of the material to control the different types of materials. And in this instance, we have exactly one. But you can add multiple rows in here and you can split up your rotary kiln to control how the diameter changes and also to build in dams to hold up your material because a lot of rotary kilns have dams in them to make the material slow down. So this is where you would do that. The kinetics and transport tabs, I will briefly talk about, but they are ways to control the kinetic models and also ways to build in particle size distribution. We do not have a direct input for particle size distribution, but you can control it through the kinetics and transport tab. And if you click the results tab, you can automatically see results inside of XtendSim. So you can plot any of the things that you can plot in Excel, you can also plot here. You can automatically see, if you go down with your mouse just a tiny bit, the bed out and the gas out, which show the throughput rate of the bed coming out and the temperature of it and the gas coming out and the temperature of the gas coming out. And if you click on the graph on the side, so this is automatically a plot that you would see.
Sorry.
Okay.
Yeah.
Inside of XtendSim, and this is also a similar plot you would see that comes out in Excel. They always follow the same x-axis where it's positioned along the process model unit. So the 0 position of the kiln is where the material comes in, and the 1 position would be where it comes out. This is an instance of temperature profiles. So the y-axis is temperature in degrees Celsius. And we have 4 lines here for the bed material, the gas, the inner wall, and the outer wall. This is actually one of the best ways to confirm your results with what you are seeing in your actual production process. So, like I said, it's very difficult to pull out material inside of a rotary kiln and figure out the composition and phase, but you can compare it with temperature profiles, and a lot of customers have been able to do that, and then they trust the results because they see a matching temperature in that way.
Okay. So what if, so in this case, we have a constant feed, but what if I want to change the feed material? Is there a...
Yeah, so we have a raw feed material block here. We have other feeds that you can see along the left side, and this is normally leak material or recycled material through the process. But the feed has the same tabs up at the top, like I said, but some of them are grayed out because you're not going to put a geometry of your feed block in. But if you click on the properties part of it, this is where you would actually put in the phase, species, and composition of your feed material. So if you click on the little black arrow for one of these,
yes.
You can see all the phases that exist inside of your CST file. You can select one of them. And if it's a solution phase like gas ideal, then you can pick specific constituents inside of the gas ideal, or you can pick all the constituents inside of the gas. And then you can put in the exact compositions that you have.
Okay. And this is a furnace, right? So this is a kiln. So it may also have effect of fuels. So how do I incorporate these fuels into my process?
So we have another input block for fuels, but if you click on that black arrow again,
okay.
Karri has worked really hard on modeling different fuels, which are not standard included in the FactSage databases. But if you purchase a KilnSimu license, whether you have a FactSage license or not, we would obviously provide the fuels to go with KilnSimu. We have 6 coal variations: coke, peat, softwood, hardwood, lots of waste materials such as waste tires, waste food, waste green, waste paper. And I think Karri is going to talk about more fuels that he modeled today at the end. But these ones are already available in KilnSimu. And if the exact fuel you want, we do not have, there are basically two options. If it's easy, we can introduce it modeling wise. If it's not so easy and straightforward, it might come at a cost. But a lot of our customers are able to take the fuels that we already have modeled and use them in conjunction with each other to get the right ratios of carbon, hydrogen, nitrogen, oxygen, and things like this.
Okay. All right.
So
So,
since we've briefly gone through this, maybe we should look at some results together.
okay. We
So as
can
I
do.
said, normally the results come in an Excel, but we've put some in a PowerPoint today.
Yes. So we have the temperature profile.
Yes, so this is the same profile I showed you inside of XtendSim
Mhm.
with the position along the x-axis and the temperature along the y-axis. The only difference is when you export into Excel, you can see it for the entire production process, not just for one process model unit. So that's what these vertical lines are for. So if you put your mouse all the way on the 0 part, this would be your first process model unit, which in the demo was a cyclone. And as soon as you cross that vertical line, you go into cyclone number 2, and then you would go into cyclone number 3, cyclone number 4, before you hit the calciner, which is the larger section. And then it goes to cyclone number 5 before it hits the rotary kiln. And then it shows the cooler at the end. So you can look at it for just one process model unit, but you can also look at it for your entire production process.
All right. So what about, I mean, if because in this process we also add some additives, so is it possible to, like, besides temperature, to also see the thermodynamics of the additives and other materials that are part of this process?
Yeah, so if you remember from XtendSim, there are about 24 graphs plotted. I'm only going to show a few today, but they were specific ones that I thought people might be interested in. So this one here shows the rate of gas species in the gas phase. So again, along the x-axis, it's still position in meters of your production process. There are still vertical lines. They just happen to be in different color. But along the y-axis, it's actually mass flow in kilograms per hour. So this would be a good way to track what is happening with your fuel, to see how much of each gas is produced or consumed at different stages of your process, where key chemical reactions might be occurring. For instance, is there a spike in CO2, and how the gas evolution trends during the heating, cooling, and reacting process. And as I said at the beginning, this is a huge topic. We've also heard today you have to increase or decrease emissions for cement production, for rotary kiln processes, and this is a good way to see if I adjust fuels, if I adjust other things in my process temperature-wise, could I decrease the amount of emissions I'm having in my gas phase?
All right. So when I look at this graph, I see species, their mass is going down, but I see a curve that is increasing with position. So what is this?
Yeah, so the legend is a bit hard to read on the PowerPoint. It's easier, obviously, when you have the results right in front of you. But where each gas is produced or consumed, you also want to know how is this affected by temperature, right? So this is actually the temperature profile of the gas phase. So it uses the axis on the right here, and it's the temperature. So you can see, okay, if I have a low temperature or if I'm having spikes in my temperature, is this causing a specific gas to be produced or consumed at this point, and you can more easily compare.
All right. Okay. So what other insights can we get from KilnSimu?
Go to the next slide. I put in two more examples. So one thing we've had a lot of interest from customers is additive tracking or mass percentage of phases in the bed because they need to get rid of a specific phase. So I put in two examples here. You could change these examples. So I have mercury here, but you could do any additive you wanted to. It doesn't have to be mercury, but it's the same sort of mass flow in kilograms per hour. So you can see just the mercury containing species in the bed, when do they form? And it is still compared to the temperature profile, but you could change this to look at other solid solution phases or other solids you want to form, chlorides, anything with bromine, fluoride, something like this. And on the right here, I have mass percent of phases in the bed. So this is also a lot of phases to look at one time. So you can set thresholds. So you can plot major phases in the bed versus minor phases in the bed. So you could zoom in on the bottom part. And this is in mass fraction, but a percentage. So you don't have to plot everything in mass flow. You can also look at mass fraction. And there are a lot of plots I'm not showing here. You can look at residence times, velocities, holdups of your material, and all of those are possible to be plotted.
And this is the highlight of this tool, that you can actually track your species which are present in the whole process over the course of entire process. Okay, so now we would like to know, okay, so if you would like to know more details on every process model units, because this is quite a lot of information, we highly recommend that you go to our website and check more details on every process model block.
So our website has been updated with all the detailed information on all of the stuff that is currently available. If you go to the next slide, Karri is going to come up. So Karri works at VTT Technical Research Center of Finland. He is the one who developed KilnSimu, but it uses ChemApp in the background, and it uses FactSage databases. So he is partnered with us at GTT. You would always purchase KilnSimu through us, but then a combination of Shivani, Stephan, myself, and Karri would help you if you have any questions. He is constantly working on updates and new features. So now he's going to highlight new things that are going to come out in KilnSimu, which are not currently covered on our website, but will be added as they are released.
Yeah.
Okay, thank you, Cassie, Shivani. That was really nice.
Okay.
Yeah, sorry. That was really nice presentation. I couldn't done it like that myself.
Yes.
Okay, so I come from VTT. It's a technical research institute in Finland. And actually the department where I'm working now is concentrating on hydrogen technology and new energy concepts. And basically that is one reason why I'm adding new features to support green energy transition into KilnSimu. So of course, with the current version, you can do oxy-fuel, CO2 mineralization, chemical looping, gasification. Then I have added for the hydrogen technology, new electrolyzer unit operation. And also I'm working with, this is kind of a demo model, so absorption tower for amine, CO2 absorption by amine. And I have built a chemical data file for that. And of course there are, I mean, maybe dozens of different kind of amines that you can use. And also, because electricity is something that's been studied, so now it's also possible to use external heating with the rotary kiln and the calciner. So electricity by conduction through the wall into the kiln, or internally using kind of energy source term to model the plasma heat, for example, also in rotary kiln and the calciner. And the calciner unit itself is kind of a circulating fluid aspect riser unit. So the extensive interface now supports this additional heat data where you can enter kind of fixed parameters to control your ambient temperature and also the heat transfer coefficient. And with those, you can then set kind of net heat flux from outside into the kiln. And also I like to emphasize that when you compile the data file, basically you can contain many different kind of phases. It can contain many different kind of phases, like of course the gas and oxide slag and the cement phases, for example, pure condensed phases. But then also it can include separate aqueous solution phase. So I've been modeling, for example, the lithium production, where we have high temperature rotary kiln processes and roasting with sulfuric acid, and also lots of aqueous processes like leaching and evaporation. But then with KilnSimu, it's possible to enable or eliminate phases in each process separately. So you can even have pure condensed water phase and also the aqueous solution phase by pizza model, for example. But then you can just use the other one when it's suitable for that process you have in mind. So this is a kind of model for VTT electrically heated kiln Elmo. It's about 10 meters in length and about half a meter in diameter. And I have, or this actually shows, added this kind of heat data table. So you can see that it contains different columns. So HGP means the heat transfer coefficient between the gas and the bed. And HGI is the heat transfer coefficient between gas and the inner surface of the wall. And HOA, it means then the heat transfer coefficient between ambient or the outside surface of the kiln and the ambient or the surroundings. And also here the TA is the temperature of the ambient. So I have set a high value for the ambient temperature, and also I have given a high value for the heat transfer coefficient. And this way I can control the incoming heat flux from outside into the kiln. And of course, then I can use these values and do the simulation. And the minus one value here means that the actual variable or the property is calculated by KilnSimu as normally. So only the positive values then are used or are used to override the value normally calculated by KilnSimu. And also these last two columns then you can use for internal heat source like in the plasma. So I have added a few parameters that you can use to enter or distribute the plasma heat into the kiln, the gas and bed side using this kind of S or sigmoid curve. And then there are a couple of parameters that you can use to control the inflection point, etc. of this S curve. And then this is the list of the new unit operations or blocks. So I have added this flash. So it's an evaporation of liquid using the phase formation target in ChemUp. And then the compressor. So of course, if you change the pressure and calculate the enthalpy change, it's of course zero. But when you compress anything, your temperature is increasing. So it uses this isoentropic efficiency to calculate the increase in temperature. And then also it can calculate using the efficiency what is then the required power, for example. And then also model for the pump and fan. Again, it uses these performances curves. And an example one is used. But then, of course, each equipment has its own performance curves, and then those maybe you need to get them and copy paste the values into the table. But that's easy to do. And then heat exchanger, and also PM proton exchange membrane electrolyzer and fuel cell model. This is for the hydrogen. And then also planning to do the pipe to calculate then the pressure drop. And also that can then be used with the pump. We have an elevation and also the friction in the straight part of the pipe and also in the bends. So it can calculate what is then the pressure drop in the piping system and how much we then need to apply power by the pump to overcome that pressure change. And also the column will be, it's not ready yet, but it's for the absorber stripper kind of column tower, and this can be then used with the liquid gas separation, like with the amine system. And then the vent, it's for flow control. So it's very handy when we want to set the flow rate in some recycle flow, for example, because when we start the simulation, we don't always know what is then the rate of the recycle, but we can fix the value and then later we can set some other parameter accordingly, but it will help initially when we start the simulation. So this is just an example of the electrolyzer stack model so that I can demonstrate how, in this case, the pump and heat exchanger and the vent is used in a flow sheet. Oops, I didn't see the magnifier glass. This one, yeah. So here with the vent, I want to recycle 1 kilo per second water, and the water goes into anode part of the electrolyzer, and then it's decomposed to oxygen and hydrogen. And the hydrogen goes from anode to cathode, and it forms hydrogen gas, and then oxygen is then removed from the anode with the water. And also we have efficiency, so only part of the heat can be converted, or part of the electricity can be converted into, let's say, hydrogen, if we measure by the high heating value of the hydrogen. So other part of the electricity, of course, is like heat, and it means also that the process needs cooling, and that is the reason why we recycle more water than what is needed. So here you can see what kind of parameters are used in the electrolyzer, and also you can change the electrolyzer into fuel cell but just by selecting the mode from the upper right corner. So basically, you give the cell area, a number of cells, cell voltage, and the temperature and the current density. And basically the cell voltage defines or determines then the efficiency. The theoretical voltage is something like 1.4, but normally there is always overvoltage due to different kind of ohmic resistances, etc. So, and also the higher the current is, then the higher the overvoltage. So with the value 2 volts, basically the efficiency in this case is equivalent to 73%. So it means that you can get the higher heating value of the produced hydrogen is equivalent. Yeah, I don't have any much more time. So 73% is then available by higher heating value in the hydrogen. Yeah. And then I also added one very useful option, this process variable block. So you can then use that to get any flow value or any parameter in a dialog window, block dialog window. And then also you can write down equations. So it has a certain syntax. So here is the name of the block, and then comes the separator bar, and then comes the name of the connector or the outgoing or incoming flow name, and then is a name for the variable, and then you can, let's say, you can get the total flow rate or the flow rate of a certain phase or phase constituent in the flow. But then you can write the equations, and also if you name any equation so that it contains some variable like this set var, and the var name refers to, in this case, to water feed block. So you can actually use this kind of equation to override the value in your feed block. So in this case, I just calculate how much makeup water is needed because of course we in the electrolysis we have the decomposition of water into oxygen and hydrogen. So that of course means that it consumes the water, and also some water is evaporated with the outgoing oxygen gas as water vapor, and also with the hydrogen. So we can calculate then what is the loss of water and use this kind of equation automatically then to set the value here in the feed block where the water, makeup water is entered into the process. Okay, so I'm sorry about that recording. I don't know how to take it off, but thank you for your attention.